everything in this unit so far, as we talk about graphing in this unit, everything has been revolving around what happens when we have x in the denominator. And as I've done many times, I've stopped to make sure I emphasize the fact you can never have 0 in the denominator. It can't be 0. So there's going to be other numbers that are involved that will cause me to have a 0. And that x equals 0 is called the restriction. Where it shows up on the graph is called an asymptote. And more on the other words as I go through some of my examples. I'm going to show you 3 quick pictures of what you need to have represented on graphing day. So everybody's structure is going to be based on, again, 1 over x, but everybody's going to pick a number to put with that x on the bottom. So I have plus 5. So don't use 5. You can put a positive number or a negative number. And here's what happens. My graph will go to, and by the way, before I talk about the graph, my x is not allowed to be what? The denominator is not allowed to be 0. What would make the denominator be 0 if x was negative 5, right? Because negative 5 and 5 would be what? That'd be 0, and that would be a bad thing to have a 0 on the bottom. So my graph goes from negative infinity all the way over there, and it comes forward into this point where it gets to this number right here. What number is right there? That's negative 5 right there. It will never, ever touch that negative 5 line right there. That is what's called an asymptote. It's kind of like a wall that it hits, all based on the restriction. So I really need to be putting this in Desmos, but there's a line here. One of the first things you should do when you make your graph is use a ruler. And this is my vertical asymptote. I'm going to abbreviate vertical asymptote. And where is it at? It's at x equals negative 5. Make sure you understand why it's at negative 5, because my function was 1 over x plus 5. And if x is negative 5, then I'm going to end up with a 0, and zeros are bad news in the denominator. Pretty much for everybody, your horizontal asymptote, which is the break between them this way, everybody's horizontal asymptote is y equals 0. You're welcome to go ahead and write that. I'm not worried about a up, down, left, right shift today. By the way, which way did I shift? Up, down, left, or right? So the normal center, the center is right here, and the normal center would have been origin, so this was definitely shifted to the left. Does that sound familiar? Why is this left 5? Because on graphing day, x has always been what? Opposite. Thank you. So again, x cannot be negative 5. The function never touches negative 5 for x. The restriction is, again, x equals negative 5. The vertical asymptote was at x equals negative 5. That's the wall and where it is. Everybody's horizontal asymptote today is going to be y equals 0. Oh, didn't do a domain yet. Remember, domain is always from where to where? Left to right. How far does my graph go to the left? It goes to negative infinity, right, on the left? Now, it comes forward, and it hits the wall because it's not allowed to equal negative 5. It hits the wall. Somebody said in second period, it goes to like negative 5.00001. And that was a good interpretation. We put negative 5 parentheses, not bracket. After negative 5, it starts again from negative 5 and goes to infinity. Everybody's domain will be a 2-part domain. Note what I typed in. I typed in 1 over 0. What's the graph of 1 over 0? There ain't one. It tells you, like, hey, something's wrong. You can't do this. So anyways, going back, me doing another one. This time I'm going to do 1 over x minus 17. My x is not allowed to be what? My x is not allowed to be 17. My denominator is not allowed to be 0, which is why my x is not allowed to be 17. So right now it looks like nothing's happening on my graph, but if I go over here to 17, what's happening? It's not touching 17. 17 is right here. It gets really, really close to 17. So I'm at 16.9. It almost looks like if I go down forever, it'll eventually get there. It doesn't. It will never touch 16 on either side. It'll never touch 17 on either side. So if you want a live look at your asymptote, what I'm going to do is I'm going to type in, again, x equals 17. That's the green line. That green line is my asymptote. You should use a ruler. What do you think you should make first, the curve or the vertical line? I think you use the vertical line to help you make the curve. By the way, again, everybody's horizontal asymptote is y equals 0. It's easier to use the ruler and make these first. Should your line touch your asymptote? No. Notice they get really, really close without touching. A domain goes from negative infinity all the way up to what? Somebody in the second period would have said 16.9999. That's a great answer. My domain is from negative infinity to what? 17. Parentheses. And then it starts again and goes from 17 to infinity. So at this point, I think I just need to mention what HOLE is for. Those of you that are doing a 6 strip, regardless, you're going to get asked about this in this unit. Ultimately, you need to know what I'm talking about when I talk about what a hole is. So let's say my 2, I'm going to change my function up a little bit, and I'm going to have 2. So those of you that are doing 6 strips, you're going to have 2 statements in the denominator. You're going to have one in the numerator as well. So this was optional, still optional. According to this, great time to participate, finish strong with me. How many restrictions am I going to have? My x is not allowed to be what right here? Thank you on -5. My x is not allowed to be what right here? X cannot be -2 either, because -2 plus 2 would be 0. Either one is a 0, that's bad, because 0 times anything is going to be 0. So I've got 2 restrictions. But look at the graph. How many disruptions, or it's called a discontinuity. How many discontinuities do you see? My graph only breaks one time. We said it was going to break at -5, because x can't be -5, and that's -5 right there was breaking, right? But you don't see it break. We said it shouldn't touch -2. Does it touch negative? Does it look like it touches -2? Now, -2 is everything on this line right here. And it does look like it touches, but here's the catch. If I click on and start scrolling, when I get to -2, what's it say? If I can stop in the right place. What's it say at -2? It says undefined. You can see there's a little tiny what right there. So what's the difference? What's special about this factor that we didn't have before? These 2 factors would do what? They would cancel out. Thank you. So any factor that cancels out, those of you who are doing 6 strips, make a factor that cancels out, and there'll be a little hole at whatever one canceled out. Whatever restriction basically canceled. It's still a discontinuity. It's still a break. Now, technically, if you're doing one of these, your domain would have 3 parts. Your domain would go negative infinity, in my case, up to -5, and then it would go -5 to -2, and then it would start again after -2 and go to infinity. Graphing the instructions always look a little bit lengthy. I just try to break them down into real simple steps. You'll write your function with just a left-right shift. Again, I already gave you this format for those of you that are currently, or everybody's listening technically. This is your format: x plus or minus some number that you pick. I'll put a question mark. Don't use 5 because I already did 5. Don't use -17, already did that. You pick one of your own. Again, if you're challenging yourself in doing 6, make one that has a hole. Again, if you're doing one with a hole, you need one that cancels out, like a x minus 2 that will cancel out, but you need one that won't cancel out, like this. With a very critical, with a ruler, make your horizontal and vertical asymptotes in 2 different colors. Make those first. It's way easier to make your curve If you use the ruler, then set up your little edges first. So then you go back on the next step, step 4, when you put your curve, make sure your curve does not touch the asymptotes. So the different colors are for your 2 different asymptotes, your vertical and your horizontal. Good question. The rest of the steps are just to write what your horizontal asymptote is, what your vertical asymptote is, what your restriction is, what your domain is, and whether yours was shifted to the left or to the right. And the whole if you did the optional bonus strip.